We talked about several different ways to solve these systems in our calculator, all right? And I asked you to do this one right here as a warm-up. And so I'm going to use the RREF, or the row reduced echelon form, to do this. I think it's the best one, it's the simplest one, and it also gives us a lot of information. So if I go over here, I'm going to go on, I'm going to go new, all right? No, I'm not going to save that. I'm going to go and I'm going to add a calculator. I'm going to go to my menu key, and I'm going to go matrix and vector, and so then I'm going to choose the row reduced echelon form. All right, so I have that in. Now I'm going to use my little shortcut key next to the 9. I'm going to select this. I'm going to create my augmented matrix, so I want a 3 by 4, and then it puts that in for me. So now I'm going to go plug that in. I do like the way that this one is written. I'm going to take all my coefficients and my answers, so 1, 3, 1, 1. So I'm going to put that in. So I'm going to go 1, 1, 3, 1, 1. I believe it was 1, 5, -2, 1. Let me go double check that real quick. So 1, 5, 2, -1. All right, so 1, 5, 2, -1. So the 2 is positive, and the 1 is the -1. All right, and then the next row was 2, 6, 3, and 2. 2, 6, 3, and 2. All right, so I have that, and this is the answer that spits back to me, which I do like. It's telling me that 1x is equal to 4, 1y is equal to -1, and 1z is equal to 0. Okay, so kind of revisited that. You'll probably see something like that on tests where you'll have to use that to be able to help you. It's a very nice one there. Okay. Now, what we want to do today is we've been talking about systems, but we're going to talk about a different system, and we're going to look at some others there. And the next system I want to look at is we're going to have systems that have quadratics in them. So we've been doing a lot of linear systems, and so 2 variable, 3 variable systems, all right? But now we're throwing in a quadratic, so it's this one that's got the x squared in it and so forth, all right? So we're going to take a look at that. Now just real quickly, if we know that it's quadratic, if it's a parabola, it looks something like this, or it could be upside down, right? We have a line. This one's a line right here. So if we have a line, what are the different ways that those could cross? Well, they could intersect like this, where we see 2 points of intersection. So I would find 2 answers. They could cross like this, where they barely touch, and that would have 1 point of intersection. Or they may not touch, and it would be no solution. Okay? Now, as I look at this one right here, it's asking me to do a couple of things. One thing it's asked me to do is it's asked me to check this to see if this is right. So I'm going to plug that in for x, the -2, and plug the y in as 4, and I'm going to check it. I'm going to check the easy one first. I'm going to do this one right here. So if I were to do that, I'm going to go 2 times -2 minus 4 equals 0. 2 times -2 is -4 minus 4 equals 0. This is -8. -8 is not equal to 0. All right, so therefore this is not the solution. Now, let's take it a step further. I want to take this one and I want to actually go find the solutions. And I'm going to use my calculator to do that. If I take a look at this first one right here, I like it. I like the way that it's written. Y equals -x squared minus 2x plus 4. This other one, I don't like the way it's written. I'm going to move the y over to the other side, make it positive. So it's going to be y equals 2x. And so now I have it written in a form that I can now go to my calculator and I can go type this in. So I'm going to go over here. I'm going to go to my calculator. I'm going to go and start fresh. So I'm going to go on, and I'm going to go new. And I'm going to tell it I don't want to save what we have in there, so no. And I want to go add a graph. So the graph I'm going to add is I'm going to put in that parabola. I'm going to go -x squared plus 2x minus 4. Let me double check that to make sure that that was right. X squared minus 2x plus 4. So I got my negatives and positive switch. So minus 2x plus 4. Okay? And there is that parabola. I'm going to hit tab, and I'm going to type in the other one. So I'm going to go 2x. I'm going to push enter. And now I have that graph, and you can see that I do have one intersection point right here, kind of in the top right. It does look like it's going to cross at the bottom, and I'm going to go find those answers. So I'm going to go menu, I'm going to go analyze graph, and I'm going to ask it to find the intersection point for me. I'm going to come over here, and I'm going to move my little trackpad to the left and to the right and click it. And so the x and the y, one x and y that works. We're looking for a point because it's a system. I got 0.828 and I got 1.66. So that's 1 point of intersection. I'm going to go back to the same thing again. I'm going to go menu. I'm going to go analyze graph. And I'm going to find intersection again. I'm going to now scroll over here to the left and to the right. And it kind of resizes the window for me. I got negative 4.83 and I got negative 9.66. Okay. So there are those two answers. So on this one, it was a two-answer situation. I've got both of those there. All right, let's try another one. So if I were to go to this next page, I have this one right here. I, again, have a quadratic, so that's quadratic. And this one down here is a linear. But I do not like the way that they are written. I'm going to move them over. So y equals negative 2x squared. I'll move the 9 over, so it's going to be a positive 9. And then on the bottom, I'll go y equals negative 2x and minus 3. Now I have them in the form that I can go plug them in. So I'm going to go plug in negative 2x squared plus 9 and negative 2x minus 3. I'm going to go start fresh. I don't want to delete any of that. So I'm just going to start new. So I'm going to go on, new, no. I don't want to save that. I'm going to go out of graph. And I'm going to go negative 2x minus 3. There's my line. And I'm going to go hit tab, and I'm going to go negative 2x squared plus 9. And there are my points of intersection. Again, I'm going to go menu, analyze graph, intersection, and I'm going to move to the left and to the right. There's the first one, negative 2, 1. I'm going to do that again, menu, analyze graph, intersection, and left and right, and there is my second one. Okay? So I can solve these systems, even if they're not linear. Excuse me, I can solve them using a graph. If they're not linear, I can't really use my matrices, and I can't really use the lens solve, the system equations that we did yesterday. Okay? Now, the thing is this, that's how we would solve these in our calculator with technology. I showed you how to do that, but what I want to do over the next couple of days is we're going to build and we're going to solve these by hand. So in order to do that, we've got to go back over and look at some factoring. So we're going to process through some factoring and work through that. Now the first rule of factoring is looking and trying to remove the GCF, the greatest common factor. So if I was going to look at these two right here, they share a 2 in common, they share an x in common, so I'm going to factor out a 2x. I'm going to put it out front. If I divide by 2x, I'm left with x in this one. So 2x squared divided by 2x is x. 4x divided by 2x is 2. So now I have it factored. I have it into its two factors. If I go take a look at this next one, same kind of deal is happening. I got 3 terms though in this one, not just a 2-term polynomial. I have a 3-term polynomial, and I'm going to look at all 3. I got to look at the 4, the 6, and the 8. They have a 2 in common. I'm going to look at the x cubed, the x squared, and the x. They have an x in common. So if I were to take that out, that leaves me 2x squared. That leaves me 3x, and that leaves me negative 4. So I have taken out my greatest common factor. Okay. That's our single most important rule. I'm going to start there every time. If I have a greatest common factor, I'm going to remove it. All right. I want to do one more of these with you, or a couple more of these with you. This is a bigger one right here on C. All right. I'm not going to do D with you. We're just going to do question C. When I look at this, I have numbers 56, 88, 32. I have x's, x squared, and x cubed, and I have y squared, y, and y. So I'm gonna look at the numbers first. 56, 88, 32, those are kind of some weirder ones. You might go, okay, they're all even, so you might take a 2 out. Okay? If I look at the x's, there's an x squared, x cubed. I can take an x squared from all three. And then the y's, there's a y squared, y, and y, so I can take a y. Now if I do that, once I do that division, 56 divided by 2 is 28. X squared, I took the x squared out there, and I took one y, so there's one y left. 88 divided by 2 is 44. There's an x squared and a y, and I took both of those and put them out front, so it's just 44. And I have 32 divided by 2, which is 16. X cubed, I took x squared out, there's an x left, and then I took a y, it's out front. All right? Now, if you notice, I'm still got all even numbers. I got 28, 44, and 16, but they're a little bit smaller. You might be able to look through there and go, oh, I see. There's a 2 in common, but there's also a 4. So if I were to divide out a 4 and put it out front, that would be 8x squared y. 28 divided by 4 is 7. There's still a y there. 44 divided by 4 is 11, excuse me. All right? And 16x divided by 4 is 4x. Now, if you notice, I got 7, 11, 4. There's nothing that I can pull out of any of those again. And then I have this here. Now, some of you may be asking, well, could I do that all in one step? The answer to that is yes. If you recognize that 56, 88, and 32, they all have a greatest common factor of that 8, then you could have divided by 8 right away, and you would have got the same answer. Okay? Last couple things here real quick in this concept or in this rule. On this one, I have a 5x. I could take out a 5x. That gives me 3x. Now, if I take the whole thing out, we don't want to put a 0 there. We want to put a 1. We're dividing. 5x divided by 5x is 1. All right? And so, sorry, I didn't leave my negative in there a while ago. Negative 15 divided by 5 is negative 3. Okay? Now, I can do that, or you could decide to take out a negative. So if I take out a negative 5x, that would cause this 3x to be positive, and it would cause that 1 to be a negative 1. Either one of those are appropriate answers. Sometimes I like the bottom one just because I don't like the negative 3x plus 1. I like to see that as positive. On this last one over here, I've got p squared plus rp. What I'm trying to show you on this one is that you don't have to pull out a number every time. Sometimes it could just be a variable. So in this case, they had the p in common. Take the p out, and there's what I would have. Okay? That's greatest common factor. The next thing I want to look at is we have another rule that is difference of two squares. Difference meaning subtraction. So I'm going to subtract. I have a squared. A squared breaks apart into a times a. B squared breaks apart into b times b. Got one positive and one negative. So if I were to try this example right here, I have a difference. So I have x and x. Take the 4 and divide it, and I would have 2 and 2. I'm going to have one positive and one negative. So x minus 2, x plus 2. I don't care which order you put those in, the plus first, the minus first, it doesn't matter as long as you have the correct symbol on. Okay? Each one needs a positive, each one needs a negative. This one right here, when we write it down, I don't like the way it looks. I'd probably go and distribute, so I'd get negative 36 and I'd get a positive x squared. Again, I still don't like the way that one's written, so I would probably rearrange it, which I'm allowed to do as long as I keep the 36 negative, so I subtract it, and I keep the x squared positive, so I'm going to put it out front as a positive. Now, I'm going to do the difference of two squares. X goes here, x goes there. 36 breaks into 6 and 6, and again, I have one positive and I have one negative. So I'd have it looking like that. Okay, let's do a couple more of these difference of two squares. I'm going to take a look at this next one. 3x squared minus 27. On this one, it's not a really perfect square here. So you got to really go back to the first rule. Remember, greatest common factor is first rule. There is a 3 in common, so I'm going to factor out the 3. It's a greatest common factor, so take the 3 out. 3x squared divided by 3 is x squared. 27 divided by 3 is 9. Now it looks a little bit more like difference of two squares. the x squared breaks apart into x and x. The 9 will factor into 3 and 3, and I got one negative, and I have one positive. Now, it is important to leave this 3 out front. We'll talk more about it a little bit later down the road. This next one, again, I would rearrange it, x to the 4th minus 16. Thinking about how we have x to the 4th, could we break it apart into two different numbers? Those two numbers we break it apart into would be x squared and x squared. 16 breaks apart into 4 and 4. Got one negative and one positive. Okay? Now this gets a little bit tricky, so be careful here. This one right here, if you notice, we've already done this one once today. That is still a difference of two squares. So it would break apart x and x, 2 and 2, one positive, one negative. All right? Now, you might think I could break that one down too. It looks the same, but I got to be careful. This is a sum. This is the sum of two squares, not the difference. So I have to leave it alone, x squared plus 4. We'll talk more about it later on, what potential factors it could have. But for now, that's the best that I can do. Okay? So if I were to ask you to do that, and taking a look at this next one here, all right, got x squared plus 49. 49 is a perfect square. It is 7 times 7. However, this is a plus, so I can't do anything with that. So we would refer to this like we did the previous day as prime or not factorable. We can talk more about it later, but for right now, that's what we're going to say. Now, this last one that we have, got y squared minus x squared. That is two squares. There is a negative. It's a subtraction. So y times y, x times x, one positive, one negative. There it is. Don't let that confuse you that there's no numbers in that one. Okay? So what we're going to do today on this page of homework, we're going to do the very first problem, which is testing -1 and 7, seeing if it plugs in. And then you have some boxes at the bottom of the page, all right, that have greatest common factor, and they have difference of two squares. I want you to do the evens or the odds for those.